not that many people were here, but there are these fantastic research blogs from Google and NVIDIA and OpenAI and whatnot, and I think for everybody who's interested to see like what's kind of going on right now in the world of machine learning and like the current trends of what like people are interested in, and even stuff that we're not going to cover, like for example deep reinforcement learning, like how to learn playing computer games with a reinforcement learning algorithm, and maybe also, you know, the Google DeepMind when they had the AlphaGo beat the first time the human world champion in the game of Go. These things are very up to date, and this post in particular references a new like part of the toolbox of TensorFlow, where you can build very slim, large networks that are still efficient. And I think TensorFlow is a good like way to get started with deep learning. Lots of great like tutorials and good documentation. And I think the most important thing is it's a very active community. Like everybody's contributing. You find tons of stuff on Stack Overflow, so it's a really like good way to get started with that kind of stuff. And I think like if you're planning to like play around with those kind of algorithms for the course project, I would really recommend to look into like doing like an MNIST or like a toy example that they walk you through, and maybe you want to do some recurrent neural networks, do the LSTM example of like learning a language model of the Pentry Bank. And so there's tons of examples out there, and the data sets are actually integrated, so you can just like, I think there's like a function called download dataset or something like that. And so it's really neat to do. So I really recommend doing that. But that was just a side note. Here is also the sign-up sheet again. You can come during the break, or we can also pass it around if you want to. And if people want to sign up for the discussions. Okay, so, and it's, again, is it now September? It is not?
No,
Seriously? One more day.
One more day.
Okay, that day. So, we're gonna talk a little bit about data sets and what is out there in terms of multimodal data that you could use for your course project. And I think mainly what I would like to talk about is, or like give you, is kind of like a set of ideas that you could implement for the course project. And but before we go there, I'd like to give you a few like important points that you need to consider in like finding the ideal data set for your course project. And I think the main thing is, like, first of all, like what you want to investigate. Like, what do you want to do? What is the task? Like, do I want to know something about the facial expressions and maybe the voice? Well, I shouldn't look at like camera angles like this then maybe, because I don't see the face, right? So if I want to know something about vloggers, you can like then think about, okay, so where could I get that? Well, obviously on YouTube you could get that, but then you need to think about, okay, so what are my search terms? How do I want to go about and find those people? Do I want to focus on one person and maybe look at their mood continuously over time? So I want to know, I don't know, like PewDiePie's or whatever, like mood with respect to first-person shooters or something like that. And then you would download like his videos, but then one of the things in his videos often is like there's tons of noise and like a lot of rapid cuts. So I think the quality of your data is very important, and but you need to identify a certain task that you would like to go about first, and I think from then on you can like start your search. The second point I think is also very important. Like, if you come up with a task for which there is no data for, or for which you will have to get IRB to get like data to download. So for example, there's this website crisis talk, I think, they are sharing their data, which is text message data, but to get their data you have to go through an apply process, you have to get your actual IRB, you have to get approval from USC, probably somebody like myself or your supervisor would have to sign the thing. So if you identify some hurdles like that, move fast, and then we might be able to make it happen, but if not, then we need a contingency plan. The size of data, quality, and consistency, I mentioned that already a little bit, but I think the size of data is very important. Sometimes, and we'll get to that, but like if you want to use deep learning, for example, I think everybody kind of like feels like, okay, this is going to be the craze. I want to learn about that, I want to try it out in a course project maybe. If you want to really do that, you need to think about a lot of data. Like you need to be able to get tons of data. And I mean like not 3 hours of data, but I mean like maybe 100 hours of data, okay? And so that's not very easy to do. And in particular, it's not easy with a lot of like high consistency. And please remember, I'm not okay with a project that's just Twitter data, okay? So we need like multimodal information. So tons of data from one modality is not enough, okay? So that's kind of like one of the constraints for the project. You had a question? No? Okay. All right. And yeah, so there's actually one data set that I'm presenting today where the data is actually actively growing, and I think that's very cool because if you think about working on that project, maybe for like a workshop paper or a conference paper, you could right now build your algorithm on the data that's available and then propose in the paper that you will submit a conference paper version of this thing, but you'll use the data that will come after you've submitted your course project. So that's a really, really strong test case. Like if you test your data or if you test your algorithm on the data that you use for training, that's not very like, wow, like you did really a good job of like overfitting this data set. But if you want to really test and validate your approach, you want to get new data, and I think there's nothing better than like data that has not even been recorded, where you can show your generalization on data that's actively growing. I think that's fantastic. Yeah, and then like what modalities do you have access to, and what modalities do you need? All right. So these are some important considerations, I think. Good resources to find data, and these are just a few, and you can like literally add to this list. And if you want to get some brownie points, in a sense, you want to go on discussion board and say like, hey, I found my course project, but while searching for my course project, I found all these great databases or like ideas and challenges, and like maybe somebody wants to pick them up, right? So just post whatever you find, if you even if it's like your second tier idea. Okay, but so a lot of really good resources on machine learning challenges. There are actually a ton of them. In particular, for example, like the AVAC challenge, which is the audio visual emotion challenge. That one has been around for like 6 years now, I think. And it is a really cool challenge because, first of all, the data set often is very similar from year to year. And sometimes it's actually the same data set, but it's a different challenge sometimes. So you can choose like, hey, I want to take that data set, but then I want to like work on the problem from 2011 with the knowledge that we have now from 2016, right? And you can try to beat the current state of the art. You can try to beat the baseline, and really, like if you just if you pick up one of those data sets, I'm not gonna like grade you based off of if you beat the baseline, right? And it's or the state of the art current best approach ever. We don't have enough time to like explore 100 different approaches, which those people are doing, and pick the best. So I think what I want you guys to have is like one experience of like going through a data set and understanding what's going on with the data, and then like building one baseline classifier that you might be able to improve upon. And then there is also Kaggle. It's a website where they collect a lot of different data sets. I think one of the data sets that you can also get from there is, it's like a Michael J. Fox Parkinson's data set where you have phone data, like phone call data plus accelerometer data, so you could look at voice and movement from one single device in a neat setup. So that's really like a nice way to get a data set from these different websites. And you know, like the Michael J. Fox Foundation data set is even for maybe a good cause, and you can feel good about that. All right. And then obviously the web is a great resource, the YouTube videos, but then like be careful about YouTube videos. There's often a lot of noise in there. They're recorded different qualities. They're recorded in people's bedrooms and offices and whatnot. And so the background is always changing. There might be people walking past in the background, so that might make it hard. But also there might be cars driving by. The microphones are all different. The cameras are all different. So you might have different results there. So you might want to consider that kind of stuff. And sometimes if you find like an interesting paper, you can ask researchers if they want to give you the data set. And so for example, Mathieu and myself, we wrote a paper this year at the LREC conference, this thing. And we proposed a data set or a data collection method with a virtual audience where you can like present in front of a virtual audience, like you guys right now, but you're real, not virtual. And you can look at people's performance. You can use Cicero, which we call it, the system. It's the virtual audience system. You can use it and like record your own data and compare, for example, presentation styles of two cultures, right? But you can also maybe ask us if we can give you our data set, and then we can work out something together on that. Okay, so there are a lot of options, and other researchers outside of USC have interesting papers, and you can just send them an email, and they can't say more than no, right? Like, so like, there's nothing to lose here. Okay, and then lastly, if you have a really like outlandish task that you want to investigate, maybe you need to record your own data. Maybe you want to, as I said, like run Cicero and like record people presenting, but maybe you wanna. We had one group 2 years ago. They built a computer game with like zombies running at you, and investigated engagement in the computer game when you have like the option to win points when you're like shooting zombies, or you're losing points, like when zombies eat you or stuff like that. And so they wanted to investigate like if there's a difference between like people's personality if they get engaged over one task versus the other. Where like in the one task you have an incentive to win something versus in the other one you have an incentive to play well, to not lose. And so there's a difference in the motivation structure on that kind of thing. All right, so I brought one of those challenges here. You can find SSPNet, like the AVIC data set on SSPNet EU, AVIC 2016. You can exchange that to 15, 14, 13, and you will find the data sets from previous years. They're really nice people. If they're not nice to you, tell me, because I know them pretty well. We'll send them a nice email so that they can send you the data from previous years. And you will have to like fill in like a user agreement. We have all of those agreements, like not for every year, but for some of the years. So if you ask me, like I really would like to have that, we can check first if I have it. If I do, I can just give you the data. Or you come to ICT and we copy the data over on a hard drive or something. And so here's kind of like the mission statement of the AVIC thing, where they want to really start to see if people are ready to understand like what's going on in facial expressions, in the voice, in gestures, and try to understand like, okay, are we able to recognize a person's emotion or affect? And as you can see here, in AVIC 2016, they're also looking at depression, and this is actually our data set. We'll come to that in a second. So this is ICT's data set. And they also have mood and emotion. So mood, we'll get to this when John Gratch is going to present. So he's going to talk about this in a way where like mood is something more long-term, where you have like a mood is set on for maybe a day, half a day, or something like that. But an emotion can be a lot shorter lived. So an emotion can be like 43 seconds or something like that. Okay. So that's kind of like a little bit of a difference. There's a data set called Ricola. It's in French. It's a cool data set with I don't know, like 50 people interacting for 5 minutes, so it's not that large of a data set. I wouldn't recommend going like very deep learning on that data set, but you could be doing something very interesting with that, I think. All right, these are all the options that you can participate in: audio-based depression, video-based depression, physiological data. You can look at synchrony of non-stationary time series. This is just a list of challenges that are available through AVIC, and I think it's very, very versatile and very interesting to do. Okay, so the next data set I have here is the Intelligence Squared US data set, and this is kind of like a really cool one that I got really excited about. So we have about 36, I think we actually increased it to 45 now, debates, and it's always 4 debaters. So they are like on a stage like here, and they like one side debates the other side over a motion, and the motion could be, for example, ban college football because of neurological issues, something like that, or some more political stuff is there too, like don't eat anything with a face and stuff like that. So there's a lot of like a variety in the debates, and I think that's one of the reasons why I think this is really interesting. So you have always 4 debaters and 2 teams, and what we have currently manually annotated is we have all the opening statements of all the individuals, so that's almost like I think 200 individuals in total, and 200 individual like opening statements and closing statements. The stuff in between we haven't worked with yet, but I think it might be like also an option if you are interested in working on like the back and forth kind of like debates. That part here in the middle, there's a lot of data. It's 45 minutes here that we have not worked with yet, and so that there's a big option here to look at that. All of their stuff is online, and the coolest thing about this is that they have all the videos, they have all the audios, they have all the transcripts with like timestamps in there, and they have labels. We know who won the debate because you can watch it and you can look at the numbers who won the debate in the end. And there are like additional research terms, like you can actually compare what the individuals talk about in the debate versus what the web thinks about this. You have even like responses from bloggers or like from people that watch the debate and they respond to the debaters online. It's a growing community, it grows every day, and I think it's super interesting. That's just one of our results that we had, and this is based on like the debate team. So am I able to know who wins the debate, and am I able to know which individual wins the debate? So there's a difference between that, because you can like correctly classify that the debate team wins, while you might not be able to identify everybody who wins, because maybe there's a really good debater on the losing team, or there's a not so great debater on the winning team as well. So that's kind of like the difference here. But what you can see is that audio, visual, and text, so the multimodal one with including everything, wins out on the other ones. And I brought a short example of how like these debates look like here. And so the data you can see is pretty decent. And if somebody doesn't know how to download videos from YouTube, I can show you, or I can Google it for you.
Organization. Ladies and gentlemen, Catherine Spencer. wildlife is somebody from Africa, from South Africa, from Zimbabwe, from Namibia, from Mozambique. Somebody who has to live with that wildlife, and somebody who has to live with the consequences of the policies that the United States and the EU often implement in relation to that wildlife. But I'm here, and I appreciate it.
So for you to understand like what we annotated, by the way, we also annotated that the camera shifts here. So you can like skip that part if you want to do facial recognition, and you don't have to analyze that because here you don't see her face. But we know when we have her frontal on the camera, and you can look at the facial expressions, you can like look at the dynamics of her gestures and stuff like that. So it's a really nicely and well prepared data set. And I want to show more of that. I kind of got addicted to watching those, like when you're in a traffic jam. It's super interesting what these people have to say about. And one thing you should know, these are all really good debaters. They're fantastic like debaters. They're from the White House, they're from think tanks, they're from universities. It's quite a really interesting group of people. All right. So, and then if you want to look at like performances of speakers that are basically at a more human level, that like baseline level where everybody's kind of at their performance. We also have the Cicero data set. We have about 50 presentations. They're all about like 5 minutes long, and I think we have 45 people, plus we have a data set from Japan, and then we have another 30 people now that we haven't even looked at, so that is like a lot of cool kind of data there. There would be some manual annotation requirements. The data isn't as nicely recorded because we don't have like studio quality cameras. We have webcams and a Kinect camera, and so in the new data set that we just recorded, we also have heart rate data. That's a bit noisy, but I think you can still work with it. So we get the heart rate from individuals' wristbands, and that is also interesting, like with respect to like public speaking anxiety. Can you detect public speaking anxiety based off of the voice fluctuations and the heart rate changes and so on? What Cicero really like investigates is so it's a project where we want to investigate like how to improve public speaking skills in individuals. And we do audiovisual sensing. We then have like feedback strategies where the virtual audience can react towards you, and we hope that you get better at public speaking through this. So why I'm saying this, because this framework, now it looks a lot better, it looks like this, is actually sort of available for you to play around with if you want to. It might require you to like learn a little bit of like Unity programming. If you want to switch up the virtual audience a little bit, and Mathieu has a lot of stuff on his plate, so we don't want to engage him too much in like helping you out. So you would have to like go through the code a little bit, but this virtual audience is kind of ready to play around with and to record data with. And we're also going to show multisense at some point, I think, where you can see how we do audiovisual recording in real time at ICT. That is also free software. You can also download that right now from ICT's website. And it is really like at a stage where you can run your own study. That's why we also have like one lecture about like study design and like study evaluation for you prepared. So that's kind of the idea there. One thing that we did with this data set was we tried to identify performances on 10 different kinds of levels, and we got lay and expert opinions. And again, we found out that audiovisual information together, so the multimodal aspects of public speaking performances, help the most and give us the most information about a person's public speaking performance. This evaluation is with respect to expert opinions. They are quite in agreement with each other, but often like you might have an individual or a lay person feel like a person didn't use their gestures enough, or like used the gestures too much, or walked around way too much on the stage, so they might have different opinions. So that so the quality of these annotations is a little bit different. But yeah, so that's kind of like another data set that we can kind of offer, give you like a little bit of an idea if you want to work with something like that. Then I would like to talk about the distress assessment interview corpus. So this is a huge corpus. We have over 500, I think it's actually like 688, not counting the face-to-face videos. Videos right now where an individual is either, so this is the face-to-face data, where an individual is talking to another individual about depression. They're being interviewed for depression. The questions are quite shallow questions about like, what do you like about LA? What's your relationship to your family? Tell me about something exciting you did last week or something like that. So we want to, like, based off of like kind of like this conversation, try to identify if a person is depressed or not. We have a lot of data also with in the context of like a virtual human interviewing a person, and that adds a little bit of like a level of control to the whole thing. So we can actually control the virtual human's behavior perfectly. We can make her smile at any time we want and investigate if the person smiled back, for example. So we can do like these interesting cues. And that's one of the things why we believe virtual humans are excellent at testing humans and at testing how humans react and how humans behave. And we have a lot of control over that. And the best thing about this is like we have released about 200 videos. So we can give you 200 interviews with annotations, with transcripts, with audio features extracted, with video features extracted, and you can try to identify if you find out, or you can try to detect if a person is depressed or not on a training set, a validation set, and I hold back the test set. So you will not be able to cheat. So that's also kind of like a good, good way to make sure that that everything is correct. So this is kind of like the data. I'll give you an idea of like how the data looks like. I brought two videos. So the interview is kind of structured in two phases, or like three phases actually. Like a warm-up phase where the two individuals, the virtual human and the real human, are building a relationship towards each other. They're building rapport, they're getting to know each other, they like start to warm up. And this is this phase.
Hi, I'm Ellie. Thanks for coming in today. I was created to talk to people in a safe and secure environment. I'm not a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes.
So, how are you doing today?
Oh, it's over. I don't know, can you see this from the back? Like that we have like this grid on the face here. So we are extracting facial expressions, we are extracting facial landmark points. We can see here if the person's smiling, so that's one of the action units that we're looking at. This is the AU12. We know like if the person is like taking a large chunk of the conversation, this rapport building phase, Ellie is taking most of the time, so the speech fraction of the individual is pretty low. Then we know where they're looking at, not on a degree kind of basis, but more or less like looking right, looking left, looking up and down, or like looking towards the virtual human, looking away from the virtual human. So that's kind of like interesting data that we have as well there. Down here is audio recordings, then we have Kinect data as well. I think we did not share the Kinect data, but if you really want that, we can also work on that. So that's the rapport building phase, and now we have like a more open-ended question phase.
When was the last time you felt really happy?
When was the last time? I don't know. Yeah, I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person. It's just happy. I guess to answer your question, probably a couple months ago.
I noticed you were hesitant on that one. Would you say you are generally a happy person?
So just to give you a little bit of an insight, like why we're doing this, so we are motivated by trying to understand like how nonverbal behavior and how behavior of individuals can be used to better assess a person's mental status, their level of depression, PTSD, etc. And so what we try to do is we record these videos, then we are able to put their data into like a plot like this. So for example here in this voice quality plot, we put their behavior on this kind of like little box plot here. What does that mean? I don't know, but it means something. We can look at it over time. So now we see a trend. There's something happening with this person, like it goes over time. And again, we only know that the person has a trend here, but do we know what it reflects or what it means? Like, not yet. That's why this box is empty right now. So we need to fill that box, and we fill that box with a lot of interviews. And we have many interviews with individuals that are not depressed, and we have many interviews with individuals that are depressed. So we can kind of like build a model, and in this case it's only a voice quality model, so unimodal, right? Where we can see, oh, this person is actually moving from not distressed towards distressed today. So there's something going on with this guy. We need to understand like what's really happening. And what we want to do is we want to provide this kind of data to doctors. And we don't want to make the assumption that if I provide the doctor with this voice quality measure, they will know, oh yeah, this person is depressed, here have these antidepressants or something like that. That's not how it works. Like a single modality or a single feature or a single indicator does not tell you if a person is depressed or not. You need to look at a lot of them. And this is what we're trying to do. We kind of try to make this comparison of like a blood sample test. These blood samples here are actually your behavior, and it's your behavior within the interview with the virtual human. And here we can see like your smile level. Oh, it's pretty good. Your tense voice is going towards the depressed part. Your posture is pretty good, and your emotional expressivity is pretty rad. But then we can show this video to a doctor and say like, hey, what do you think about this? This guy's fine because I can see his video about his emotional expressivity. He's just not interested in talking to the virtual human. So like in the end, the human will make the assessment, but we try to give them more information so that they can make a better assessment. All right. Okay, so very briefly, I would like to also mention that there are different types of annotations, and I think sometimes you want to consider different annotation types for your project. The discrete ones are more like binary, yes, no, or they could be like on a level scale, like low, mid, high. But these are like more or less like boxes where you have to discretely categorize someone. But then there are also continuous ones like emotion, intensity, or valence that could be like from 0 to 100. So it's more fine-grained kind of separation. And you can also have the depression score in the continuous range. So you can give a person a questionnaire, they fill that questionnaire in, the questionnaire gives you a metric, which is actually like a value between, for example, like 0 and 50 or something like that, right? So what I want to do, or want to mention here is that given if you have different types of annotations or different types of targets that you want to get at, you need to think about different metrics, okay? We're going to come to that, but keep it in mind that metrics are important for machine learning, and we will need to work out the best metric to evaluate your model based off of the task, okay? And often you can get annotations through these different sources, so questionnaires, experts, or Mechanical Turk. Experts might not be easy to get for you, so you could substitute that with peers, so you could ask each other, like, hey, do you want to rate this thing? Or you send a website, hey, we have these videos put there, like, do you want to rate those, I don't know, advertisements based on their funniness scale or something like that, okay? An MTurk costs a little bit of money, but it's also very cool to reach a lot of people to annotate your data very quickly, like in a day or two. Okay, metrics, important. All right, so let's quickly go through a couple of things with respect to audio. Are there any questions about data sets right now? Because I will then kind of give you a rundown of a few audio resources and tools that you can get, and they are basically complementing each other. They're not like you should only use this one. You can, like, if I use that one, you can't like touch that one. It's not like that. You can use all of them. You can complement each other, and I'll show why this is actually happening. So the first one I would like to introduce is CoverRap. It's called the Collaborative Voice Analysis Repository. I'm part of that, and the idea behind this was that all of us researchers know a lot of articles, like from the 70s up to the current time, and we love those articles, and sometimes there is an implementation that I have of one of those articles that I wrote here, and I put it on GitHub. I want to share it, but it might have a bug, right? And so this guy maybe tells me, hey, you have a bug, and so I modify my code, I change it, and we were thinking that this process was way too scattered and it's like not very controllable. So what we decided is we throw everything together into one repository on GitHub. We write a wrapper around all our functions, so you can basically say CoverWrap feature extraction, and you give your data folder where all your WAV files are in, or you write your wrapper around that and like make it crawl your entire data set with different folders, and it extracts for you all these kinds of cool features. It is available up here, and you can have it implement, like the implementations are available in MATLAB, C++, and Python. C++ and Python are only libraries, so you can only call them. You can't modify them. It's not the source code. The source code is MATLAB. Okay? So if you want to modify something, you need to work with MATLAB. The idea with CoverUp was also to not cover every other person's algorithms, because there are so many voice analysis algorithms that are just duplicated 100 times on the web. There's like a million times of how to extract MFCCs, and we only post one that is a bit outlandish and a bit different from the others, and it's pulse synchronized, and so it's synchronized with the glottal fold pulse. And then we also focus on voice quality features, which no one else does. So this is a bit more of a different kind of way to extract. However, caution, it's very slow on very large files, so don't give it like an hour. You'll wait a week until it's done. So that's not good. But if you give it 5 minutes, you wait 3 minutes, right? So chunk it up, put in shorter amounts of data, so it will create these crazy matrices that grow, I think cubically, so don't do it. No big files. 10 minutes is fine. 20 minutes is getting close. But never try an hour. I did that. And then the other one is OpenSmile, and OpenSmile's approach is a bit different. It's not open, even though it says open Smile, but it's a company, Audiering. I think they have the source code available, but it's very weird, like C code. It's very efficient, but very low level. It's not very accessible. I think MATLAB is a lot more accessible for somebody who wants to tinker with algorithms. And also the difference of the approach is that they guzzle up everything. Like they try to include everything in their algorithms. And so what they do is they extract features in 3 groups. So they're energy-related features, spectral-related features, and voicing-related features. And what they then do is for each of those features extract like 1 billion of these functionals. I mentioned that earlier this week, I think, or last week, where they basically extract min, max, mean, median, percentiles, and whatnot of everything of these. And one of the things that is happening here is, like for example, sometimes what they do is like they give like a second of data into the system, and you get a lot more data points than I think you need. So CoverUp is a lot more like narrowed down. It only gives you like 20 different features, but you can do something afterwards with them. This gives you like all the features in one big chunk, and it becomes like this very like high-dimensional data problem that you will have to deal with. Caution. There's a lot of different kinds of configurations. So there are configurations for AVIC 2014, AVIC 2012, AVIC 2011. So they actually provide these features in these audiovisual emotion challenges, but they often use different types of configurations of like what features they're extracting. This is just one of the configurations that they use. I think this was this year's challenge. Okay. So yeah, it's an opportunity, but also caution there. All right. Then one more tool that I would like to highlight is PROT or PROT, and this one is really funky and cool in the sense that what you can do with this is you can really like go into the very details of the voice, and you can look at the speech behavior at a very fine-grained level. And so it is used for annotation, visualization, and generation. You can script with it, but you're stuck with that. So what does that mean? Like you cannot take prot functions and import them into C++ or some other code. If you find out a way to do that without writing files to the file system and calling their libraries, please let me know. I'm very interested in getting this done. It has a great documentation. It looks a bit like a website from the 80s or from the 90s, but it's very detailed, and it gives you a lot of really good steps. And it also allows you to do batch processing. So even though it looks like you have to go load a file, click I want to do this, click I want to do that, click I want to do that, you can actually batch that. So you can like write a script that does all these calls and then like run it on a folder or run it on 10 folders or something like that. So it's kind of neat like that. It gets a bit clunky if you do that, but yeah, so, and I would like to show you a little bit like how it looks like. I'm just gonna copy this real quick. So this is how prot looks like. So for example here, I'm in the vowel editor. You can get that if you go here, you make, like you say, sound. I want to create the sound with the vowel editor. So you see here the different operations you can do. Like you can record stuff, you can annotate stuff, you can synthesize, and so on. And like right now we're in the vowel editor, and this goes back to like the vowel space that we talked about. So I can make this thing here say mainstream American English vowels like in a sequence. If it, no, why not? Why is it not playing? I might need to open it again. you can hear like how funky that is. You can then also maybe change the slope, so you can make the vowel. And here's the thing, like you might have thought like, okay, you're crazy about like saying that vowels are independent of like the frequency of the pitch. They are. Like here's like I can do the same thing in a different pitch, but the formants stay the same. I can add a slope to this. I can make it go down. So you can play around with like what happens with voices, and you can also obviously look at like some speech here. So view and edit. I get this view. Like what I have already here is like so I can show the pulses where the vocal folds are vibrating. I can zoom in on that. I can say like, okay, I want to know this. I zoom in. I move this here, so you can see the pulses here and how synchronous they are. You can follow the blue line here is the pitch contour. The red dots are the formants. You can like show the formants. You can not show the formants. You can evaluate intensity of speech. Then we talked about how you can change from like a narrow band to a broadband spectrogram or spectrum, and here we have a narrow band. This is more like the broadband one. Oops. Nope. So yeah, you can play around with this and get maybe like a better feel for what is really going on, okay? So it's kind of like a cool thing to play around with. And I think annotations you like add through somewhere here. You can say like, I want annotations, and then down here you can start like writing into the file and say like, hey, this is that word, and this is that word, and this is silence, pauses, and so on. So this is kind of like a neat tool to explore the voice and play around with it. There are many tutorials on what you can do with it, and so yeah, if it's interesting to you, I would look into it. There are also scripts available that you can use to extract some special features. So for example, Prot has cool features that are related to articulation rate that are very high level, so you can look at like speech rate and how fast somebody is speaking. So that would be interesting, for example, with respect to like debates. Like, is it good to be a very fast speaker, very loud speaker, versus a very slow speaker? This is also just very quickly, like when you're recording audio data, think about these kind of things. Try not to compress your data to MP3s. You're destroying something. That also already adds a little bit of a problem with respect to, let's say, YouTube videos. They are already compressed, so think about these kind of things. There are noise sources, and if you're recording your own data, I would say bring the microphone as close to the mouth of the person that you want to record as possible, and try to reduce the noise from the surroundings. Okay. With respect to speech recognition, you can use Google and IBM Watson on your own data, and like if you download something from YouTube, you can try that out as well. They are really good nowadays. We're actually also in preparation to like set up a tutorial for Watson, like how you can like send your data there and it gets transcribed by Watson and sends back the data, and then you can like utilize that. We're setting that up right now. Everybody can get an account. It's like an IBM Bluemix account, and your first 1,000 minutes are free. And I think we have processed more than 1,000 minutes, and we never paid anything. So I don't know. And maybe it's free for everybody and all the time, but we don't know. All right. So very briefly then, on the course project, I just added a few ideas. We had these slides before. So these are some potential topics. Think about it. I don't know, I came up with this in 3 minutes, honestly. Like, you can come up with a lot more interesting, like, project names and, or project ideas and titles and whatnot, but it's really not that hard. And we also put online a document that is not the syllabus. Where is it? That has a few ideas in it, but it also has some like rough guidelines of what we're expecting, and we're gonna update that document. And this is this document. It's online. You can download it. There's a schedule, and just a reminder. There's a bunch of like where are the example topics? That's not the document. Which one is it? Wait, is it?
Samples.
Oh yeah, sample projects. But I had a few more. It didn't save, I guess. Okay, so we'll add some sample projects here, but it also has guidelines here about what is required in the report. Please make sure that you follow those. There are rough guidelines. If you want to go beyond that, you're free to do so. But like, I mean, don't go crazy, but try to keep like within the range of what we expect. We don't like want to see just like one-pagers and like some bullet points. Like in the pre-proposal that might be fine, but once we're moving further in the course, we need to like in the end we want a nice paper actually. Okay, so there are some hints, and I think we need to update that. I'm not sure if this is the newest version and I deleted the other one. We'll figure it out. But yeah, so this is a document that's going to be updated regularly. All right. Okay, let's do a 5-minute break and then we can continue with the discussion about the voice. And the discussion leaders are here.